Here's problem number 16 from our review packet. We're going to deal with this region R, which is enclosed by the lines x equals 0, which is the y-axis, y equals 5, which is that horizontal line, and the graph of y equals x squared plus 1, which looks something like this. And again, we're only in the first quadrant, so we're really only looking at this little piece here. And we're going to revolve it around the y-axis, so we end up getting a solid that looks a lot like a bowl. All right? To go from there, these individual discs are dy thick, and they have a cross-sectional area of pi r squared, where r is this distance right there. Well, that distance is measured horizontally, and so I'm going to need to know what the coordinate is for the two edges of here, and I've got to do it all in terms of y. Well, this location right here is going to be over 0 up y. This location here is going to be something comma y, and we're going to have to solve this equation to find out what that x value is. We have to solve that for x. So let's go over here and say if y is equal to x squared plus 1, then y minus 1 is equal to x squared, and then plus or minus the square root of y minus 1 is equal to x. Well, the positive version of this is right there, and the negative version of that is over there. So we're just going to be interested in the positive version, and that's going to be the square root of y minus 1. So to write the integral expression that we want for volume, it's going to be the integral, it's going to be in dy, it's going to be pi r squared, and the r is this distance here, which is square root of y minus 1 minus 0, square root of y minus 1. And we're going to do this from the lowest y value, that happens when x is 0 and y is equal to 1, to the highest y value, and that happens at y equals 5. So there we have it. The integral, let's pull the pi out. Square root and square root cancel each other out. So we get y minus 1 dy from 1 to 5. So this is pi times 1 half y squared minus y as evaluated from 1 to 5. So this is going to be pi times 25 over 2 minus 5 minus 1 half minus 1. Let's see if we can clean that up a little bit more. Let's see what we got. Let's distribute this negative through. I get 25 halves minus 1 half is 24 halves. That ends up being 12. I get 5 plus 1, negative 5 plus 1, which is negative 4, which gives me 8 pi, and that is the answer.